Welcome to this lesson on ratios. Today we're going to talk about how to write ratios, equivalent ratios, and comparing ratios. The essential question for today's lesson is how do you write ratios and equivalent ratios? So by the end of the lesson you should be able to answer that question. So the first thing we need to talk about are ratios and equivalent ratios because we're learning about those and what they are. So in your vocabulary, you know that you have your words, and a ratio is a comparison of two numbers by division. And how we write ratios, so if we were looking at a class and we were looking at the number of girls to boys, so girls to boys, we would write our ratio in that order. You can't change the numbers around because if you change the numbers around and put the number of boys where the number of girls is supposed to go, then if you look at it, you'll say, oh, well, then there's 12 boys in the class when there's actually 15. So in this case, if there's 15 girls, you would write 15, and you can use a colon, and 12 boys, so 15 to 12, or you could write 15 to 12. Or another way, you can use your fraction bar and write 15 to 12. So those are all the same ratio, just written in three different ways. Now equivalent ratios are ratios that name the same comparison using different numbers. So they're kind of like equivalent fractions. You find them the exact same way, multiplying and dividing by the same number. So they give that same ratio, but they use different numbers. So in this case, we had 15 girls to 12 boys. And if we simplify that, if we divide them both by 3, because we can, because both of them are divisible by 3, and we get 5 to 4, we know that 15 to 12 is equivalent to 5 to 4. So 15 to 12 is equivalent to 5 to 4. So these are equivalent ratios. All right, so let's start using this information. So here we have writing ratios. Writing ratios is only tricky when it talks about writing them in three different ways. Students often get that confused with equivalent ratios. An equivalent ratio is not a different way to write the ratio. An equivalent ratio is using different numbers. So when you're writing them in different ways, you should use the same numbers but different symbols. So we have to look. The party mix recipe requires how many cups of pretzels? Well, we look and we see that it's 4. And we know that it also needs 2 cups of bagel chips. Okay, this is important to know because when we try to write the ratio of pretzels to bagel chips, we need to know how much is being used. So we can write the ratios in 3 different ways. The first, using a colon, so we would write 4 to 2. The second way, using words, so 4 to 2. And the third way, using that fraction bar, so 4 to 2. All right, so another way that we can write a ratio, or not another way, but another ratio that we can look at, is the recipe makes a total of 8 cups of party mix. So this is not another way, this is our new ratio. So if we want to write the ratio of pretzels to total party mix, we would have to look and see that, okay, we have 8 cups of party mix, but we need the number of cups of pretzels first. The number of cups of pretzels is 4, so that would go first. So it would be 4 to, the total cups of party mix is 8, so 4 to 8. I can now write it using my word, 4 to 8. And I can write it using the fraction bar, 4 to 8. All right, so let's go ahead and give this a shot. You have a spot here where you can write down these different examples. I'd like you to try them. It should only take you a couple of seconds. So first we want to look at the number of bagel chips to peanuts. Right, so I want you to look, find out what the ratio would be, and then write it in 3 different ways. All right, so you should have gotten 2 cups of bagel chips to 1 cup of peanuts. So what this actually means is when you're making the mix, for every 2 cups of bagel chips that you put in, you have to put in 1 cup of peanuts if you want the recipe to be correct. So when you have your party mix in total, you know that you're going to have more bagel chips than you actually have peanuts. So that's one way of writing it. Another way is 2 to 1, and the other way is 2 to 1. All right, so let's try another one. Go ahead and pause, and you can try writing the total party mix to pretzels 3 different ways. All right, so the total number of cups for party mix is 8 to 4 cups of pretzels, 8 to 4, and 8 to 4. Now, we did this example before, but before we did the amount of pretzels to the total amount of party mix. And yes, it does make a difference that the order is in a different order. All right, so one more, cheese crackers to peanuts. So if I put in 1 cup of cheese crackers, I have to put in 1 cup of peanuts. 1 cup of cheese crackers to 1 cup of peanuts, and 1 to 1. So now you'll have a series of reflection questions. I'm going to do this first one with you. Otherwise, when you see a reflection question, those are questions that you need to answer on your own. You can pause and do it when you see it, or you can wait till the end of the lesson to go back and answer them all. It's up to you. So the first reflection question for this lesson is, what does it mean when the terms in a ratio are equal? So I want you to think, when the terms in the ratio are equal, what does that mean for those items? Well, let's look at our cheese crackers to peanuts. If the number in the ratio is equal, that means that the amount of cheese crackers that we're putting in is the same as the amount of peanuts that we're putting in. So if I'm putting in 1 cup of cheese crackers, I have to put in 1 cup of peanuts. Let's say there was a class of 15 girls and 15 boys. Since the number is equal, that means that it's the same amount of boys as there are girls. So when you see numbers in a ratio that are equal, that means that there is the same amount of each of the things in that ratio. All right, moving along to equivalent ratios. Again, remember, equivalent ratios name the same comparison using different numbers. Okay, and you need to use multiplication or division to make those equivalent ratios. You cannot use addition or subtraction. If you use addition or subtraction, you're not actually adding the same amount. So when you double something, so if I double 4, that means that I put in 4 and then I put in another 4. But if I were just to do 4 plus 2, I'm not actually doubling it. So if I were to just add numbers in, it's not going to be the same as multiplying or dividing. You have to continue to add the same amount every time. So when we add the same amount every time, it becomes repeated addition. And we know repeated addition turns into multiplication. All right, so we're in charge of making punch for an upcoming school dance. The punch recipe makes 5 cups of punch by mixing 3 cups of cranberry juice to 2 cups of apple juice. Makes sense because you pour in the 3 cups, pour in 2 cups, and together that gives you 5 total cups. Nothing disappears, nothing miraculously gets added. Your total amount of juice is going to count on how much of each juice you put in. Right, so first we're going to look at, what is the ratio of cranberry juice to apple juice? Well, we know that there's 3 cups of cranberry juice, so that's first, to 2 cups of apple juice. So our ratio is 3 to 2. So do you think, looking at this, that your juice is going to taste more like cranberry juice or more like apple juice? If you said cranberry juice, you'd be correct. Since there's more cranberry juice in the ratio, it probably means that the juice is going to taste a little bit more like cranberry than it is apple. It could also mean, though, that the cranberry juice isn't very strong, so we are adding less apple juice so we don't mask it. But because we're putting in more cranberry juice, that would tell me that I'm trying to make my punch taste more like cranberry juice. All right, part B. So we have to increase the recipe to serve a large number of people. So we're going to fill in the boxes in this table, okay, or in this, to find the ratio of cranberry juice to apple juice when we double it and triple it. So what that means is if I put in 3 cups of cranberry juice to 2 cups of apple juice, if I double my ratio and put in 6 cups of cranberry juice, I have to do the same thing to the apple juice and put in 4 cups of apple juice. So I multiplied them both by 2. This means I'll make more juice, but my punch will still taste the same in the end. Okay, same thing here. If I triple it and put in 9 cups of cranberry juice, I have to triple the amount of apple juice and put in 6 cups. So what this now means is if I double it, I need 6 cups of cranberry juice and 4 cups of apple juice, which now would give me a total of 10 cups of punch. So when I add these two things together, that should give me the total, because it's the 2 parts of the juice would give me the total of the juice. And when I triple it, again, the 9 cups of cranberry juice plus the 6 cups of apple juice would give me 15 total cups of juice. All right, so the ratios we found in Part B are equivalent to 3 to 2. We're going to find 3 other ratios that are equivalent to 3 to 2. Since you can multiply or divide by any numbers, let's take a look at 3 and 2. Both of those can only be divided by 1. Dividing by 1 doesn't give you an equivalent ratio. It gives you the same ratio. So let's continue to multiply and continue moving up our number line. So in this case, if we stopped at tripling it, why not go on to multiplying by 4? So you have 3 to 2. If you multiply them both by 4, you get 12 to 8. So there's one equivalent fraction. If I multiply it by 5, I get 15 to 10. And if I multiply it by 6 over 6, I get 18 to 12. Okay, again, I wrote them differently in different ways, but they're still the same thing. They're still equivalent ratios. So now, since I know that adding the 2 amounts gives me the total amount of cups, if I want to make 40 cups of punch, and I know that when I add my juices together, that gives me the total amount of punch, I need to figure out, well, how much of each juice would I use in order to keep my recipe tasting the same, so using the same ratio, and adding to 40 cups. So in this case, I know that if I do 12 plus 8, that gives me 20 cups of juice. That's not enough. If I add 15 plus 10, so do 15 cups of cranberry juice plus 10 cups of apple juice, that's only going to give me 25 total cups of juice. Still not going to be enough. Then if I do 18 cups of cranberry juice to 12 cups of apple juice, I know that that gives me 40 total cups of juice. So I know that I can use 18 cups of cranberry juice, 12 cups of apple juice. It's going to keep my recipe tasting the same, but it's also going to give me the 40 cups of punch that I need. All right, so let's try this. We're going to complete each pair of equivalent ratios. I'll do the first one with you, then you're going to do the second 2 on your own. This is where knowing your math facts comes in handy, because if I know how to go from 6 to 24, which I know I multiplied by 4, then I know what to do to the top, because if I multiply by 4 to one number, then I have to do the same to the other number. So I know that this has to be 20. So now I'm going to go ahead and erase these, and I want you to solve for these 2 problems. When you come back, we'll check your answer. All right, so here you should have found that you multiplied by 8, so you should have gotten 32. And here you actually divided by 2, so you should have gotten 15. All right, now the next thing you're going to do is you're going to find 3 equivalent ratios. So now you're finding a piece of the ratio. Now you're going to find your own equivalent ratios. Again, I'll do the first one with you, and then the next two you'll do on your own. To make it easy on yourself, just start with the smallest number that you can multiply by or divide by. Okay, so here you have 6 to 8. I know 6 and 8 are both even, so I can divide both 6 and 8 by 2. If I divide 6 by 2, I get 3. If I divide 8 by 2, I get 4. I can't divide them by anything else, so I put a comma to separate, so a semicolon to separate, so I know my next one is a new ratio. So why don't we multiply both by 2? So I get 6 times 2 is 12, 8 times 2 is 16. Okay, and now let's multiply by 3. 6 times 3 is 18. 8 times 3 is 24. Alright, so now you have two ratios that I'd like you to try and find three equivalent ratios for on your own. Remember, you can use division. When you come back, we'll check your answers. Please note, though, that if I don't give an answer that matches yours, we can double check it when you come to class tomorrow. So pause, and when you come back, we'll check your answers. Alright, so here you could have found that you got 4 to 3. So we're looking here, 4 to 3. 8 to 6, 12 to 9, because you could have divided, okay, for all of them, or you could have gotten 48 to 36. Yeah. And moving down to 15 to 10, you could have divided and gotten 3 to 2, multiplied by 2 and gotten 30 to 20, multiplied by 3 and gotten 45 to 30. You could have multiplied by 4 and gotten 60 to 40. Again, if you have an answer here that I don't have listed or did not say, be sure to ask in class tomorrow and we can double check. There are so many answers that there's no way that I could give you all of them without making this video last forever. Right, and don't forget to do your reflection questions. Last piece, comparing ratios. Anna's recipe for lemonade called for 2 cups of lemon juice and 3 cups of water. Bailey's recipe calls for 3 cups of lemon juice and 5 cups of water. If in Anna's recipe, the ratio of lemon juice to water is, okay, so her ratio of lemon juice to water is 2 to 3. So for every 2 cups of lemon juice she puts in 3 cups of water. Okay, so we're going to complete the table to make more equivalent ratios. So 2 to 3, if I double that, I get 4 to 6. Okay, so again, tasting the same but making more. If I triple it, I put in 6 cups of lemon juice to 9 cups of water. And now if I do it times 5, okay, so I would get 10 cups of lemon juice and I would have to put in 15 cups of water. Right, so there's my table for Anna's recipe. If I look at Bailey's recipe, in Bailey's recipe, the ratio is 3 cups of lemon juice to 5 cups of water. Now it's important that I put it in the same order because if I'm comparing Anna's to Bailey's and I change these around, so if I put 5 to 3, then I would be comparing the amount of lemon juice in Anna's to the amount of water in Bailey's. And that's not going to work out well for us. Then we're comparing two completely different things. All right, so we're going to complete the table with the equivalent ratios. Right? So I know that if I want to triple the amount, I would have to put in 3 times the amount of lemon juice, which would be 9 cups. And I would have to triple the amount of water, which would be 15 cups. Times 4 would mean 12 cups of lemon juice and 20 cups of water, because I'm multiplying by 4. Okay, so here, to get 25 cups of water, I know I multiplied by 5, so I have to do the same on top, and that would give me 15 cups of lemon juice. So now I have tables for both Bailey's lemon juice and Anna's lemon juice. So now I need to find something in Anna's juice and Bailey's juice that is the same, because their ratios might not show up to be equal, but there might be a part of their ratios that are equal that can help us out. Okay, so in each table, and actually we can try and make this a little easier to see. In each table, there's a spot where the amount of water is the same, right? So you see here, we have 15 cups of water, and in Bailey's, we have one where we have 15 cups of water. Right, so looking at those ratios, we want to look and see what we can find out by comparing those. So I know that in Anna's, she had the 10 cups of lemon juice to 15 cups of water, and in Bailey's, there was 9 cups of lemon juice to 15 cups of water. So looking at this, now that we know that the amount of water is the same, looking at this, who makes the stronger lemonade? If you said Anna, you would be correct. How did you know that Anna made the stronger lemonade? We know that Anna made the stronger lemonade because even though she had the same amount of water as Bailey, she put in more lemon juice. That means the lemon flavor is going to come through more in her juice than in Bailey's juice. So notice we couldn't see that necessarily when we had the original ratio. So when we just had 2 to 3 and we were comparing it to 3 to 5, yes, it looks like Bailey puts in more lemon juice than Anna. However, she also put in more water. But if you look at it, Anna only puts in 1 more cup of water than she does lemon juice, whereas Bailey puts in 2 more cups of water than she does lemon juice. So that's going to dilute her juice a little bit more than Anna does. But that was much easier to see when we compared these ratios. Okay, when we found that the 10 cups of lemon juice to the 15 cups of water was more than the 9 cups of lemon juice to the 15 cups of water. All right. So the ratio of lemon juice to water is stronger, in the stronger recipe is write an inequality symbols to compare this. So we did this before, so when we compare this, we know that the 10 to 15 is larger than the 9 to 15, so we know that the 2 to 3 is bigger than the 3 to 5. Again, this is much like when you're comparing fractions. You just have to remember that fractions and ratios are different. All right, so your last question. How do you write ratios and equivalent ratios? So this is for you to answer on your own. So if you were to explain to somebody, how do you write a ratio? You just need to tell me, what do you look at? How do you write them? What do you use? Do you use words? Do you use a fraction bar? What do you use to write ratios? And then how do you make equivalent ratios? What do you use? And what is really important to remember when you make those equivalent ratios? I'm not looking for a novel here. A couple of sentences for each will be perfect. Always remember, if you have questions, make sure to write them down so we can talk about them in class tomorrow.